Now we are going to talk about the selection sort. So in selection sort, what we basically do is it is a simple comparison based sorting algorithm. So we do compare elements, and how we do it is basically in each iteration we try to look for the smallest element, and then we have the array into two different parts. One is sorted and the another one is unsorted. The sorted elements, they are kept first, and then we always iterate through the unsorted array, and then we swap the last element from the sorted array with the unsorted array. What I mean by that is, let's try to see this using an example. Here we have 51428. So we are trying to find the smallest element from the whole list. Initially, we are going to iterate through all the five elements. So the smallest element is the 1. Therefore, we will swap the first element, which is 5, with the 1. Okay, so now the array becomes 15428. Now this part 1 is sorted, but this part 5428 is not sorted, right? After the first iteration, the first element is going to be sorted, right? So now in the second iteration, what we are going to do is that we are going to start from the 5, which is the unsorted part. Okay, so now we are going to look for the smallest element. So in this particular unsorted array, the smallest element is 2. So what we are going to do is that we are going to swap the beginning of this unsorted array with the smallest element. Therefore the 2 is going to come over here. So what it will become, it will become 1 2, and then we have the 4 5 8, right? So 1 2 is already sorted, and now the algorithm will continue. We can also put a check that if there is no swapping, that means the array is already sorted, and we can stop with the algorithm. But if we want to do a complete dry run for this problem, then 4 5 8, we will look for the smallest element, which is the 4, and we will swap 4 with the itself, right? So therefore it will be the same, 1 2 4, and then now it is the same thing, right? And in the next iteration, what will happen is that we are going to look into the 5 8 sub part, and the smallest element is 5. Therefore the 5 will get replaced by itself, and in the last iteration, what will happen is that we now have single part, which is 8. So it will get swapped by itself. Okay, so the final sorted array is now 1 2 4 5 8. So let's also solve this problem using in selection sort. Okay, so what we are doing is basically we have to iterate n times. So for I in range n, where n is basically the length of the array. Now what we are going to do is, for each iteration we are going to start from I index. So for j in range, we want to start from I, and we have to go for the whole array, right? Now for each iteration, what we are going to do is we are going to uh, check the index for the smallest element, right? So let's just have the min index variable. Let's set it to I, which is the basically the first element for each iteration. So what we are going to do is we are going to check if the current element, which is the nums of j, if this element is smaller than nums of min index, then what will happen is basically we are going to update the minimum index. So minimum index is going to be j, right? And what we are going to do finally is basically, now we know the min index then what we are going to do is we are going to swap the element which is the beginning of the subarray, that is nums I, with we want to swap this with nums of min index, and we can do the swapping of two numbers using this particular syntax in Python. Nums of min index and nums of I. So this is how we can do this, and finally what we are going to do is we are going to return the nums. Let me run this code. Okay, so return. I think I do not have the proper indentation. So the correct code is this, and let's hit run. Nums of min index, and we are still getting some error. I want to see what the error is. Oh, actually I have a syntax error. This is nums. Okay, now it is accepted. Let's let's submit the solution. Okay, so we are waiting for the submission. Now we are getting the time limit exceeded error, which I was already expecting. This is because the outer loop it runs for n time, and the inner loop it also runs for all in the range of n. Okay, so the time complexity for this particular solution is big O of n square. Although we are not taking any extra space, therefore the space complexity for this solution is big O of 1. Because of the big O of n square time complexity, it is taking too much time, and therefore we are getting the time limit exceeded error. Okay.